This was the solar system 4.6 billion years ago, when the Sun, Earth, and even other planets had not yet been born. A massive gas cloud drifted through space, composed of countless hydrogen and helium atoms, if not for several supernova explosions occurring somewhere in the universe. This gas cloud might have continued drifting through space, unchanged. However, the shockwaves from those supernova explosions compressed the gas cloud, causing temperatures at its center to rise rapidly, finally igniting nuclear fusion. Thus, about 4.5 billion years ago, the Sun finally began to shine, officially born. However, the Sun back then, compared to the warm Sun we see today, was much more unstable and produced far less heat. During the same period, Earth also began forming from the same cosmic dust and gas, gradually coalescing into a disc-shaped celestial body. This disk attracted surrounding floating dust fragments and even asteroids, making it heavier and heavier. Finally, a solid core of metal formed inside. The core was heated by powerful gravity, reaching temperatures of 6,000 degrees, and gradually formed a liquid outer core around it. It was this solid metal core and the convection between the liquid outer core that created Earth's natural dynamo. As a result, Earth's magnetic field was born. This magnetic field is actually a natural barrier that still protects our fragile lives today, blocking intense cosmic radiation. However, back then on Earth, there was no life worth protecting. The entire planet was a boiling ball of lava, glowing red hot and steaming. During this period, young Earth faced its first major catastrophe. Earth collided with a protoplanet. This celestial body was later named Theia by scientists. After their violent collision, the ejected fragments came together, forming the mysterious satellite we call the Moon. Interestingly, after this collision, Earth's rotation became extremely fast, with days lasting only 5 hours, but over hundreds of millions of years. The Moon's gravity gradually took effect, and Earth's rotation slowly decelerated to what it is today. Even so, Earth back then was hardly a habitable planet. The entire Earth was covered in lava floods, with meteor showers constantly falling from the sky, leaving no room for any life to survive. Earth in that era was like Venus consumed by volcanoes, with acid rain falling everywhere. But amazingly, about 3.7 billion years ago, the first life forms appeared on Earth. They were single-celled microorganisms that didn't need oxygen at all, because there was no oxygen on Earth then. For 2 billion years, these microorganisms lived in warm shallows, gradually building limestone structures called stromatolites. These are traces of life from the Archean era that survive to this day. Those most primitive organisms didn't even have cell nuclei. Extremely simple. Because of this extremely simple structure, they could survive until today, even thriving in springs over 100 degrees, or in cold, highly acidic waters, living quite well. After some time, some of these bacteria began to learn photosynthesis. Initially, the oxygen produced was used to oxidize iron in rocks, but about 2.45 billion years ago, oxygen production exceeded consumption and began escaping into the atmosphere, triggering the Great Oxidation Event. For organisms that didn't need oxygen, oxygen was actually toxic. This biological disaster caused mass extinctions and their remains later became the earliest oil resources. When the Proterozoic era began, about 2.46 billion years ago, atmospheric oxygen reached 2%, only 1/10 of our current air. So if we went back to that era without masks, we would suffocate directly from oxygen deficiency. Even earlier, Earth's atmosphere was mainly composed of methane and carbon dioxide. And these gases caused exactly the greenhouse effect we fear most today. However, at that time, this greenhouse effect actually became a lifesaver, keeping Earth at a temperature that wasn't too cold. But once oxygen began consuming methane, the greenhouse effect weakened, causing temperatures to drop rapidly. Although oxygen levels rose, this didn't mean we would find it comfortable. On the contrary, we'd probably freeze to death, because Earth was about to enter its longest ice age in history, the Huronian Ice Age. This ice age lasted 300 million years. Earth, once as hot as Venus, became a planet completely covered in ice. Temperatures in some areas even dropped to between -20 and -70 degrees. In such conditions, it was impossible to nurture any new life. But miraculously, some bacteria managed to survive, like cyanobacteria and archaea, these microorganisms that already existed. Hearing this, you might think life should have remained stuck at this primitive stage. So the question is, how did dinosaurs and humans eventually emerge? What could change all this? Was our sun. During the 300 million years of the Ice Age, the sun gradually became hotter and finally melted most of the thick ice layers on Earth. This also opened the path for multicellular organisms and complex plants. From that moment on, everything started moving. Over the next billion years, life on Earth became increasingly diverse, with more and more variety. Most importantly, life finally took a crucial step from ocean to land. By the way, when Earth warmed again, entering the Carboniferous period, it was an era like a asteroid-fueled zoo. About 300 million years ago, long before dinosaurs appeared, Earth was already filled with giant insects and spiders. The land itself was constantly changing. About 750 million years ago, the supercontinent Rodinia began to crack and gradually split apart. The separated landmasses floated on the ocean and eventually came together again, forming another supercontinent called Pannotia. But soon after, Pannotia also met its fate of disintegration. The split landmasses collided with each other, gradually forming today's mountain ranges. Finally, about 335 million years ago, these drifting landmasses combined again, forming Pangaea, this massive land assembly. And this enormous continent later slowly broke apart, becoming the familiar Africa, Eurasia, Americas, both north and south. Why did dinosaurs go extinct? The common explanation is a massive asteroid hit Earth, causing this disaster. Scientists have even identified the crater left by the impact, located in what is now the Gulf of Mexico region. However, the Permian mass extinction that occurred at the boundary between Paleozoic and Mesozoic eras is less well known. But in fact, this extinction was the most catastrophic of the 5 major extinctions in Earth's recorded history. We often say, if dinosaurs hadn't gone extinct, humans might never have emerged. But if that Permian mass extinction hadn't occurred, dinosaurs might never have appeared either. Nevertheless, Earth at that time showed no signs of impending disaster. The Permian period had two major biological groups that had thrived for nearly 40 million years. The diapsids, ancestors of modern reptiles, and the synapsids, ancestors of mammals. In terms of position, they might have even started the path to evolving into intelligent life. But this evolutionary path never continued. In other words, we humans exist in this world not only because dinosaurs disappeared, but also thanks to this mass extinction that occurred long before dinosaurs. In that distant Permian era, although Earth's plants and animals evolved well, the overall environment was completely unsuitable for human survival. It could even be said to be the complete opposite. Overall, the climate was dry, though it varied by region. It was somewhat similar to today's climate. However, the atmospheric composition then would be unbearable for modern humans. Although oxygen levels were 1% higher than today, carbon dioxide concentrations were about 3 times higher than now. In such air, we would likely not just get headaches. We might lose consciousness from poisoning, especially in the late Permian. Carbon dioxide levels soared to 12 times modern levels. But more difficult to adapt to than the air were the terrifying animals of that time. The oceans were full of giant sharks and bony fish swimming freely through the waters. On land were small mammals, massive herbivorous parasaurs, and gorgonopsids distantly related to humans. Running everywhere, gorgonopsids looked like a cross between dogs and dinosaurs. Their danger level was as terrifying as mixing a dog with a T-Rex. They looked like large dogs, but stood up to 3 meters tall. Hairless predators. Their mouths contained saber-like, sharp teeth, terrifying just to look at. Once encountering such predators, escaping unharmed was nearly impossible. However, scientists believe they were among the ancestors of mammals, meaning we're actually distant relatives. Unfortunately, these creatures also went extinct at the end of the Permian. According to paleontologist research, this mass extinction eliminated up to 96% of marine species. The situation on land was even more severe than imaginable. This was the only time in Earth's history when even insects couldn't escape disaster. Nearly 80% of insect species went extinct. Terrestrial vertebrates, including gorgonopsids, also lost about 70% of their species. From a geological time perspective, this disaster happened extremely quickly, taking only about 60,000 to 200,000 years. Scientists theorize the main cause of this mass extinction was massive basaltic volcanic eruptions, releasing enormous amounts of lava. This very lava formed the famous Siberian traps. The series of volcanic eruptions released trillions of tons of sulfur dioxide and carbon dioxide into the atmosphere and filled the oceans with toxic sulfides. The result was a dramatic rise in Earth's temperature. Carbon dioxide levels skyrocketed from 400 ppm to 2,500 ppm. All of this happened at the boundary between the Permian and Triassic periods, just before dinosaurs were about to appear.